Hi, I'm Adrian Pappas, and I'm a research associate for product development at 1AucseearSDint. And we are a company based in San Diego, California, and our core technology focuses on real-time, label-free, impedance-based cell monitoring technology. And today I'm going to show you one of those systems, which is our 1AucseearSDint platform. Now, the entire system consists of merely the 1AucseearSDint station, as well as an Apple iPad to run your experiment, as well as to display the data. The 1AucseearSDint system itself is powered by a USB power cable, and so it can actually be powered through either a laptop, or you can use the Apple power adapter that comes with the iPad. And so the communication between the 1AucseearSDint station as well as the iPad is through this Wi-Fi signal transmitter located at the end of the power cable as well. And actually the iPad can detect the signal and connect to it just fine, and it correlates to the serial number located on front of the 1AucseearSDint station. Now, this unit is small enough such that you can place it inside of an incubator for your experiment, and you can keep the iPad outside to monitor your data acquired. As you can see, the station itself has two separate cradles for two individual plates, and each cradle has a set of pogo pins located on the top and the bottom, and it allows for essentially your impedance-based measurements. And so you can see at the bottom of your ePlate L8 devices there are a set of contact pads that correspond to the pogo pins. Each plate is securely locked in, and for the cradle design is such that you even have access to your wells during your experiment. Now, the plates are designed and developed for the 1AucseearSDint platform, such that they contain 8 wells per device, and each of them contains a set of electrodes on the bottom of the well that allow you to monitor your cell attachment growth and other responses label-free. And as you can see, there is also, if you look very closely, an area at the bottom of the well that does not contain electrodes. And this was implemented such that you can perform analysis via microscopy in the same well on the same samples. In general, the area of the bottom of the well is 0.64 centimeters squared, and which correlates to about 2 to 3 times the size of your standard 96 well area, standard 96 well plate area. So to take you through a general walkthrough of the software, just very briefly, this is the home screen of the 1AucseearSDint software, and from here you're actually prompted to either start a new experiment, to perform data analysis on an experiment that you have already run, or to resume an experiment that is actually currently running. And so let's say, for instance, you wanted to start a new experiment. From here, you're actually prompted to pick one of the 4 predefined assays, or to pick an assay that you would like to set up a different assay aside from these 4. And so the standard assays that come with a proliferation, toxicity, adhesion, cell QC, and receptor ligand assays. And so let's just say, for instance, we wanted to set up a typical adhesion assay. Here, you're prompted to either set it up with a standard protocol or a user-defined protocol. So in case you have a previously saved template, this is where you would actually load the template for the experiment. So let's say we're using the standard protocol. Immediately you're prompted to actually set the steps for your experiments. Now this is where you actually modify the number of sweeps for your experiment, how many data points you'd like to acquire, the frequency of those data points, and the duration between those data points that you actually want to acquire. And for all of the assays, the first step is actually very important, and it's actually, you cannot modify it, and this is actually the background measurement. Now this is actually very critical, as I mentioned, because this background measurement will establish your baseline impedance measurement, which your subsequent cell index readings will be compared in reference to. And so it essentially establishes your origin based on the impedance coming from just the media without the cells. And so all the cell index measurements you acquire after that will be specifically due to the fact of your cells being there. So as I mentioned, you can modify the duration of each step, the number of sweeps, which means pretty much the number of data points to acquire, the interval between each step, and as well as you can also add several steps of your own or delete steps if you prefer. And so once we've modified the scheduling of your experiment, you can go immediately into the layout. Right here, it's a bird's eye view of both of the ePlate L8s actually. But in case you would like to just set up one E-plate, it's fine. You can actually set the well property of, let's say, or let's say the second cradle you would not like to use it. Just click on Used. It'll prompt you to confirm that yes, you would like to omit this data, and that's fine. You can run one plate. And you can also set it back on if in case you do happen to change your mind. It's back on. And so here in the layout page you can edit your very basic cell type, cell number, titration factor, as well as add any compounds that you would like. Now from here, once you've edited your experimental procedure as well as the layout, you're actually ready to start your experiment. And so as an example, here I have a plate with PBS. And so let's actually insert it into the cradle 1. I'm going to define my column 2 or cradle 2 as going to be unused. And it's not critical, but we could define the cell type as, let's say, A549. Now if you choose not to, you can actually leave the layout blank as well and start your experiment, and it'll be totally fine. I'm sorry, I forgot to mention, but as you can see, this button is now green. Prior to that, once the device was not in there and engaged, this was actually grayed out. And so now that the fact that it's green indicates that it is ready to go, and you're actually ready to start your experiment. So we click play, and it'll immediately prompt you to enter a name for your experiment if you like, or you can use the default serial, which corresponds to a date as well as a series of numbers to distinguish between experiments. And so let's just say we want to use a standard, and it'll automatically take your first measurement. And so as you can see here, once we loaded all the wells into the graph, it actually took our origin measurement or background measurement. And from this point on, you'll actually remove your plate from the station and seed your cells in here. And so all the subsequent cell index readings will be based in reference to this background measurement. And so that's basically the entire setup. So to summarize, I took you through the iCELLigent setup in general, the station itself as well as the iPad to run the software, what it consists of and how it works. I ran through a general overview of the software itself, how to set up an experiment in general. And we also went into the functionality of the device experimental workflow, how to actually put your cells in there, when to obtain your background measurement, and so forth. And that's basically it. So tune into our other videos and I'll walk you through an actual experimental setup for each of these 4 individual predefined assays and how to set that up. And I'm Adrian Pappas from 1Aucseear Biosciences. Thank you for watching.